In this question, we have to find out the unit of electrical energy in terms of fundamental SI unit. Although there are various forms of energies, mechanical, all types of mechanical energy, thermal energy, sound, electrical, and like all the forms of energies have the same unit, that is joule. And you can express joules in the terms of fundamental SI unit, but in this question, we will find out first of all the joule in terms of fundamental from its specific circuit. Okay, so because they have mentioned here electrical energy. So, what is the electrical energy provided to this circuit? So, this is the current, a conventional current flowing to the circuit. So, what is the total power delivered to the circuit? Is the power is equals to the current multiplied by the EMF of a circuit. Okay, you can use a simple equation W is equals to Fs cos theta to find out a unit of energy in terms of fundamental SI unit, but we will take specific this circuit and its equation to find the final answer, right? So power is equals to the energy delivered to the circuit per unit time. So if you want to find out the energy, you have to multiply the power multiplied by the time. Since the power equation for the electrical circuit is I multiplied by the EMF multiplied by the time, so we will try to find out the unit from this equation, right? Now, in terms of units, the unit of current is ampere multiplied by the EMF, or the potential difference, have a unit joule per coulomb, because if you remember, the potential difference can also be written as the work done per unit charge. So from here, the voltage, the volts is equals to the joule per coulomb multiplied by the unit of the time is second. Now the coulomb, the quantity coulomb is a derived quantity, okay? And the coulomb is equals to the ampere second, because the charge is equals to the current multiplied by the time taken. So that's why you can put the value, I mean the coulomb can be written as ampere second multiplied by the second. So this is cancelled out, and now we have just left joule, which I already told you that the unit of energy is joule, but it's good that we have seen it from another equation. Now the joule is equals to the Newton times meter, okay? And the Newton is a unit of force, and the force is equals to the ma according to Newton's second law, right? So that's why the Newton should be equals to kilogram meter per second square times meter. So hence this is the fundamental SI unit of energy, which in which all the units are the fundamental SI units. Hi, in this video, we will try to identify which one of the following quantities is a scalar quantity. Now, it is very easy to identify. Obviously, it should be a kinetic energy, but why not the other quantities are scalar? And what is a meaning of scalar quantity? Let us explore it. So, the scalar quantity is a physical quantity which can completely defined by its magnitude along its unit. It doesn't require any direction. It doesn't have any direction. Okay, it's magnitude along its unit. So, for example, the speed, time, and all forms of energies, these are all scalar quantities, power, etc. Right? Now, how do we measure the kinetic energy? You just need the magnitude of the mass and the speed. So half mv square, this is the amount of energy possessed by the object due to its motion. Okay. Now, why not the other quantities are scalar quantities? Because I will show you the different examples. Let's say if a car is moving, so this is the north, south, east, and west. This is a reference position, and a car is moving towards east. So if it is moving with 20 meter per second, so 20 meter per second can be considered its speed. But when we will write the velocity, so that is a vector quantity which cannot be just defined by this value, but we also would say towards east. So it's is its direction. In the same manner, let's say you have studied the projectile motion. So if you have thrown a ball and it is making this elliptical path, so you see that at all the positions, the velocity direction is changing because it is moving in a curved path. So velocity direction is changing, and hence momentum direction is also changing, because the momentum is also a vector quantity that is always in a direction of velocity, in a direction of motion. Okay. And what about the free fall motion? This is another, the very famous example. You must know about the free fall motion, that if you release a ball in an absence of air resistance, so how does it change its position? In every new second, in every next second, it covers more distance, right? So at all the points, its acceleration is equals to negative g, which is towards the center of the earth. So acceleration always have a direction. If a car is speeding up, then acceleration will be in the direction of motion. But if you apply the brakes, now the acceleration will be in opposite direction of motion. So acceleration also have a direction, and by the way, the acceleration's direction is always the same in the direction of force. So the right option should be the option C, that is kinetic energy. You may wonder that why every object falls down, but it is more accurately to say that every object falls towards center of earth or center of any celestial body due to its gravity. And how do we visualize the gravity? We visualize the gravity with the help of these gravitational field lines that you see on my screen. All of these field lines are directed towards center. The reason, because if we will release any object close to the surface of earth, where the gravitational field strength or gravity is almost same uniform, then it will fall down towards the center with a constant acceleration due to gravity, that is negative g. In the case of earth, it is negative 9.8 meter per second square. So these are the gravitational field line, and this value can vary with respect to the other planets. Now, in our question is about the free fall motion. Why? Because we assume that the air resistance is negligible. So when air resistance is negligible, then there is a no force exerted on an object except the force of gravity. That's why the acceleration is equal to the net force over mass, and that is equal to negative mg. We will consider the direction of the force also, so that's why it is negative g. So in all the free fall motions, acceleration is always taken as negative g. Okay. Now in our question, you see that at the time t is equal to 0, if you release a ball, it will, what pattern, if we take the screenshot, if we take the pictures of this falling ball after every 1 second, so then you will capture something like this pattern. You will observe that in every next second it will cover more and more distance, because we claim that it is moving with a constant acceleration. And for a constant acceleration, dear students, you know that the distance time graph, I'm talking about distance time graph, increases proportionally, sorry, exponentially, like this. So what will be the distance covered in the fourth second when we know acceleration is constant? So why not apply Seurat equations? Because these equations deal all the problems related to free fall motion. So S is equals to ut plus half at square, right? Now we know that we have released it from the rest. So initial speed is 0. So the S is equals to just 1 over 2, and A is negative g, and the time t square. So which is negative 1 over 2 gt square. So if you want to know what is the distance covered in a fourth second, so there are two ways to prove it. So the method one is dear students, we will calculate the distance covered in 3 seconds and the distance covered in 4 seconds, and then we will subtract it. So I mean to say, why not if we find that what is the distance covered in the third second and the distance covered in the fourth second? Let's call it S4, right? And I'm saying distance, so I will just take a positive values. So don't you think this is the distance covered in the fourth second, which is S4 minus S3? So what is the distance covered in the 3 seconds? It is equals to 1 over 2. Now I'm not writing negative sign because I'm finding distance into, better is that if we take 10 and 3 seconds, 3 square. So it will be how much? It will be 90 over 2, which is 45 meters. It means that this ball has covered 45 meter in first 3 seconds. In the same manner, S4 will be equals to 1 over 2 into 10 into 4 square. So that will be equals to 160 over 2, which is 80 meter. So the answer is 80 minus 45. That should be equals to 35 meter. It means it covered 35 meter in the fourth second, not in 4 seconds, in the fourth second. Now you can also find out the same answer by taking ratio, because once you know that the distance is directly proportional to the t square because the g value is constant, you can take a ratio, right? You can say S4 over S3 over S1 is equals to the 4 seconds divided by 1. So that will be equals to 16 times S1. In the same manner, the S3 over S1 will be equals to the 3 square over 1 square. That will be equals to 9S1. So from here you can subtract them because I told you this is the distance covered in the fourth second, right? So that will be 7S1, and the distance covered in a 1 second is always 5 meter. Okay, so that is 35 meter. And how do I get 5 meter? 1 over 2 into 10 into 1 square. Okay, so I hope the both methods you get all of that. See you in the next video. Hi, this interesting question is about the graphs of the motion. The graph that you see in this diagram is the speed time graph of an object, which shows us that the speed with respect to time is increasing and increasing, and then it gets its maximum value and then it is decreasing, which means that that object is accelerating. Now, in this question, we have to identify that which one of the following distance time graph gives us this speed time graph. Okay, so we will go back from the velocity time to distance time graph. So let us investigate it. But first of all, I will explain you that what is the speed and how do we measure it, how do we calculate it graphically. Okay. So speed is nothing, it is just the rate of change of distance. Okay, we cannot say it is the rate of change of displacement, that is the velocity, and velocity is a vector quantity. It is the rate of change of distance. It tells us that how fast or slow the object moves, its distance changes with respect to time. So that's why whenever we calculate the speed from the graph, it is basically the delta s over delta t, which is gradient of distance time graph. So it means that we will see that which one of these following graphs gradient gives us that shape of graph. Okay, so let us see one by one. Okay, in a first option, which is option A, well, many of you can easily guess that it is a wrong answer. Why? Because if you notice that there is a equal change in the distance with respect to time in every next interval, the object covers the equal distance, right? It means that, dear students, this quantity is changing equally with respect to this quantity. So this is obviously the graph of a uniform speed. It means the object is moving with a constant speed. So if I draw its graph, then it would be a horizontal line. So that should be, this should be the graph of velocity. So it is obviously not giving us that curved graph. Okay, now we will go directly after A, we will go directly to C. Okay, remember one thing, if you are having a here a variable speed, like this is the shape of the graph, right? It's a parabolic shape. We can never have the distance time graph in a same shape. The reason is because if you see, even at that point, the if I draw a tangent line, this tangent line has a maximum steepness, right? And then that tangent line steepness is decreasing, and at that point the tangent line is horizontal. And a horizontal line means if I measure the speed at that point, the velocity or the speed will be zero. Okay, because the slope or the gradient of a horizontal line is zero. So which means that in the starting at the time t is equal to zero, we have a maximum speed. All right. So we can draw from this point, and it is getting zero at some time. You see exactly at that time where the speed was zero, I'm showing you the graph touching the time axis, and then we will keep moving it in this. Then the velocity is getting, well, the velocity, the speed is positive, right? So because this is a speed time graph, so you can draw the same like this graph, which is obviously once again not giving us this graph, right? So option C is also wrong. Let's move to the option D. So for option D, you see the distance time graph is flattened almost in the middle. All right. So I'm talking about at that point where it is flattened. It means that at that point speed should be zero. So I just want to show you at the different points the tangent line, so you can have an idea. And I'm going to draw the tangent line at these points. And with the help of the steepness of those tangent lines, you can get idea that how the speed is generally changing. So you see that the speed is decreasing, and then it is once again increasing, right? And all this speed is already always a positive because it's a scalar quantity, right? So anyways, at that point the velocity or the speed is zero. So if I draw its graph, so dear students, you can see it is obviously a very high value in the start, and then it is getting zero, and then it is increasing to the same value once again. This is not a correct option. What about this? So let us see. Let's explore. Obviously, this should be the right answer, option B. But let's see how is it right answer. So do you see in the start at the time t is equal to zero, the speed is zero, right? And then the speed is increasing, and exactly at this point where I'm drawing tangent line is the speed maximum. And after that, speed is positively decreasing, or the velocity is positively decreasing. Speed is always positive. So ultimately at that point your speed is once again zero. So exactly at this time the speed is maximum, and it is starting from zero, so it should be like this. All right. And and then again it will go like this, right? So exactly at that time the speed is again zero, so which is obviously 100% relating with this graph. So the right answer should be option B. Hi, this question is an application of Newton's laws of motion. You see in a diagram the two boxes are placed side by side, and the one box has a mass m, whereas the another box has a mass 2m. This is a box X and Y. We have to find out the resultant force applied by X on Y, but provided this very important thing that this is a total force F that is exerted on the whole system. It is directly applied on the box X, not directly applied on a Y, but this force you can say is moving the whole system. And one more thing, important thing to mention, that this whole system of masses, they are moving with a constant speed v, which is provided. Now the question is, if a force is applied on the system of boxes, then why it is moving with constant speed. We will investigate it in a free body diagram, or and we will also discuss about the pair of forces and internal forces. So watch the whole video. So I will draw the free body diagram of the whole system later on, but first of all, let's investigate that what are the internal forces. So dear students, you know that this is a force applied by the ground or by the floor on this mass m, so which is equals to the force of gravity, the weight of this box. So if it is mg, so this is a normal force 1, that is equals to mg. Now the second mass y, the box y, have a twice the mass, so that's why it must have the 2 times more force of gravity, and that is equals to this upward force applied by the floor. So this is equals to 2 mg. These are the internal forces, and this is the external force which is applied on a whole system. And the one very important internal force is actually the pair of force that I want to show you here, that this is a box x and this is a y. X is pushing y in this direction, so I can say this is the force applied by x on y, whereas the same magnitude but in opposite direction, there's another force which is applied by the y on x. These are the pair of the forces, and in IB, there are the pair of forces are very important question usually asked. So these are the, and what we need to calculate is this force. Okay, so we can apply Newton's second law to write its value, that it is equals to my times acceleration. Since it is moving with a constant velocity, so that's why the acceleration is 0. So that's why this force obviously should be 0. There's a no force applied on y, so because the system is moving with a constant speed. Now, uh, so if this represents the whole system, then this is a total force applied on a system to the right side. And the if it is moving with a constant speed, then there must be an equal amount of force applied to the left side, which should be some kind of resistive forces. It can be most probably the frictional force, which is not mentioned in a question. So what we find out finally, that the force resultant force exerted on y is equal to 0. So for this reason, option A is the right answer, which says 0 newtons. This question discusses the application of Newton's second law, which you know is always applied to the accelerating system. You can see here a elevator or the lift that carries a load and their combined mass is 750 kg. And what we need to calculate in this question is the force of tension in a cable. So the tension in a cable is in this direction, and provided information is that the acceleration is downward, and that acceleration is, I would say, negative 2 meter per second square because of its direction. Otherwise the magnitude is 2 meter per second square. Now this downward acceleration means that the system's weight is more than the force of tension, but we need to calculate the tension in a cable. At the end of the video, I will compare this scenario with this scenario if you are in a lift, and how your apparent weight changes. So you should solve any forces question by first of all drawing the free body diagram, and I'm supposing that this is a system contains a load and the elevator, and the force of tension is obviously upward. So this is the tension in a cable, so this is a force of tension D, and the weight should be downward and it should be more than, so I will draw the lengthy arrow, so let's say it is mg. Now the second step is always to write its equation by using Newton laws of motion, and since it is accelerating downward, so we should use Newton's second law. So according to Newton's second law, you know F is equals to ma, but this F is the resultant force, so that's why I'm writing it F net, the resultant force. And in our case, since the mg is more than the force of tension, right? So you can write this equation like this: ft minus mg is equals to m into negative a. Otherwise, you can also write mg minus ft is equals to ma. So we can find out the value of force of tension. The force of tension in a cable will be equals to mg minus ma. So the weight of the elevator is 750 times 10 minus 750 times 2. So this is a force of tension in a cable. And its answer is 6000 Newton, which you can also write 6.0 kilo Newton. So that's why its answer should be option B. Now let's quickly compare this situation. So for example, if her mass is 50 kg, so her mg value should be equals to 500 Newton. So that is called the real weight. Now, so if she accelerates, she is in an elevator and the elevator is accelerating down with negative 2 meter per second square. So then the bottom scale, this weight measuring machine, will not read 500 Newton. Apparently, her weight will be decreased. And how much is that? So in this scenario, the force is the normal force applied by the machine, and this is her weight. So so the normal force minus mg is equals to negative ma, and the normal force is equals to, because this normal force right now is its real, sorry, apparent weight. So you can put the value and find its answer. That will be obviously less than 500 Newton, because when this elevator is accelerating down, so she is not able to press the machine with such a amount of force, with such a strength, because the machine, elevator, and everything inside is accelerating down. So she is unable to press down the surface of the bottom scale. So that's why the bottom scale will not read its that value of the normal force. So that will read the force less than 500 Newton. So this is happens in the accelerating system when your real weight is not equal to your apparent weight. Okay, this question addresses the idea that how do we calculate work done, or how do we determine the work done from the force distance graph or the force displacement graph. So right in this graph, you see a force, a variable force is applied on an object and it is traveling the distance, so distance is increasing. So what is the work done from the P to Q? So I will show you the two or three different scenarios in which the force is changing. So the first scenario is, don't you think this one? So if a box is attached with a spring and you compress the spring and then you release it. So while this object, this box will be moving towards its equilibrium position, the force will be changing. The spring force will be changing. It will be decreasing. But if you compress the spring, then that spring force will be increasing its magnitude. So if I draw the graph, taking force, the magnitude of the force on a y-axis and the magnitude of the distance on x-axis, right? So so the graph will be like this proportion line, and all the area that is under the graph, under this line, is representing the work done. So it means that in a force displacement graph or the force position graph, this area represents the work done on that object. Okay, and then this work done is equal to the change of energy, because work done is the transfer of energy. I want to quickly show you the two other scenarios also, in which the force is increasing or changing, and how do we find work done. So for example, on this car, if a force is increasing, right, so you see that it is traveling more and more distance in every next interval. So let's say this is a position P and this is a position Q. During the position P and Q, the force is still increasing, but what is the work done during that? It is just like I have shown you here, that we find out the area under the graph to find out the work done. We will do the same. We will find out the area under the graph, this whole area, which is the sum of these two sections of the graph, y and Z that represents the work done. And in the same manner, this is another scenario. If the force of tension in a cable is increasing and it is accelerating up, so if it is position P and this is a position Q, so during this, what is the work done? That is once again the area under the force displacement graph. So it is sum of sections Y plus C that represents the total work done from P to Q. So the right answer should be the option C. In this question, we have to find out the power that is required to maintain the constant velocity of the car despite of the resistive forces. Either it's a air drag or it's a frictional force by the ground. So the car engine is giving the constant thrust of 1500 newtons. So this is a force that the engine is applying to maintain its constant velocity, because there are the other forces. So that might be the force of the friction, the dynamic friction, or that might be the air drag, so FP. So in order to overcome these resistive forces, a 1500 newton of drag is required to move it with a constant velocity. And what is a constant velocity? Because it is moving with a constant speed, so you can find out simple: 100-meter is covered in 5 seconds, so that is 20 meter per second. Now, what is the power? Before we directly apply the equation, let me show you what is the relationship between the power and force and velocity. So you know the power generally is the rate at which work is done. Now, this work done is equals to right now the F force into the displacement, and in fact it is the, because the constant force is applied by the engine, so the displacement is increasing with respect to time. So when the power is constant, sorry, when the speed is constant, so you can say that this delta S over delta T, which is the rate of change of displacement, which is average velocity, is equals to instantaneous velocity. When the velocity is constant, then the instantaneous velocity at any instant of time can be written as average velocity, which is equals to delta S over delta T, is a gradient of displacement time graph. So the power, that's why it's a product of the force and the velocity, and we have to simply multiply it. 1500 multiplied by the 20, that will give us the 30,000 watts. So we can write this 30 kilowatts. So that's why the right answer is option D. 30 kilowatt is required to maintain constant velocity of the car. Hi, in this question, we will try to investigate either the kinetic energy and momentum are conserved during the inelastic collision or not. So, if they are not conserved or any one of them is not conserved, then what is the reason behind it? We will prove it with the help of laws of conservation of energy and momentum, as well as with the equations. So kindly stick to the video, we will prove it. First of all, I need to show you the examples of inelastic collision. So this is a one of the example, like all the example which involve embedding of something into the other. For example, if this is a bullet that is fired towards this block and it is moving with some initial velocity u, and at a very next moment it is going to embed in this block, so it will look like this when it will embed. And the moment when it will hit the block, its energy will be delivered to the block, due to which the block will not be able to stay at that point. It will move along a curved path to conserve the energy, but not the 100% of energy will be conserved. I will show you later on. So this is how it will go to its new position. So it will move like this. Anyways, let me show you another example. This scenario is also very famous in past papers. IB exams. So let's say if this card is moving with some initial velocity and it is not moving, so it have no momentum. So if their collision is inelastic, let's say the first card upon hitting the second one, it it stick with the other one, right? So right after the collision, they both are moving as a one system. So this is also an example of inelastic collision. So for example, after the collision, right after immediately after, so its common velocity is v. So we will investigate either momentum and kinetic energy as conserved or not. So we start with this thing that they mention categorically that there's a no external force in a question. So if there's a no external force, it means that the rate of change of momentum of system should be zero. Okay, which means that the change of momentum of system is zero. So if the change of momentum of system is zero, it means that the change of momentum of the card 1 is equals to the negative of the change of momentum of the card 2. Or in other words, dear students, you can say the sum of the change of momentums of both cards is zero. So we can only take the idea, like the only conclusion that we can draw from this one is that if the change of momentums of both cards are equal in opposite direction, or they are equal in magnitude, which means that the total momentum before the collision, if it has a mass m and both have a mass m, so what is the total momentum before the collision? That is mu. So mu is equals to the total momentum after collision. Now it's a system of masses, so it have a total mass 2m. So 2m into v. This is what it means. So what is a common velocity that we get from here? So obviously we get a conclusion that the momentum is obviously conserved, and that's why we are able to find out the common velocity, which is equals to u over 2. And if you wonder that why I have written this thing that the both changes or momentums are equal in opposite direction, just because obeying the Newton's third law, which says that the same force will be applied on both of them, but in opposite direction. When the forces are equal in magnitude and in opposite direction, then their changes of momentums will also be equal. So this is, so it means the momentum is conserved. Now let's quickly derive the result, that is the kinetic energy conserved or not. So what is the total kinetic energy before collision? So only the card 1 was moving. So initial kinetic energy is just due to the kinetic energy of this card, whereas the other card was at rest, so it have a no kinetic energy. And what about after the collision? So the kinetic energy, if the kinetic energy is conserved, then the after collision kinetic energy should be equal to this one. But you will see it is not, because after the collision the kinetic energy of the system is the sum of the masses, which is 2m, into the speed, which is u over 2. We just have seen from this equation, so we will take it squared, so it is 1 over 2 into 2m. It is equals to u square over 4, and you can take 2 over 4 outside, and inside we have 1 over 2 mu square. And what we get, interesting result, that 1 over 2 into initial kinetic energy. So it means that the final kinetic energy is reduced to just one half of initial kinetic energy, which is obviously we get a result that is not conserved during the inelastic collision. Either it's a card collision or it's a embedding cases in which an object embeds into the another object. In all of these scenarios, kinetic energy is not conserved, because energy is transformed into some other forms like sound or heat, a minor amount of heat as well. In fact, a minor amount of sound as well, and major amount of heat. So for this question from this exam, the option A is correct, which says that only momentum is conserved. Hello, this question is about the thermal energy transfer from a liquid And obviously, you see that this is a liquid. Why? Because you see inside the liquid, I have shown you intentionally that the molecules have a more space between them. So we are going to take heat out of the system so that this liquid will undergo the phase change until it will convert into this solid form. So basically, what is a phase change? First of all, try to understand this thing. So it is a process during which the one state of matter converts into another state of matter at a constant temperature, into another state of matter at constant temperature. So now one valid question that someone can ask, that if the temperature does not change, then why is that? Because the heat is continuously going out of the system. So heat is coming out of the system by any mechanism. So then why the temperature is not changing? So the reason is that, and this reason is applicable for all the phase change, either liquid is freezing to the solid, or the liquid is converting into is vaporizing. Okay, so the reason is the heat that is transferred out of the system during this, so chemical bonds are forming between them. And secondly, you see that the distance between the mean position between the molecules are greater than in the solid form. The molecules are close in a solid form. So I can say the molecules in a liquid form have a more intermolecular forces of attraction because the molecules are at a larger distance, at a larger position. So what is happening? The heat that is taken out of the system is not changing the temperature, rather it is decreasing this intermolecular forces of attraction. So it means that the heat is independent of the change of temperature. So that's why there should be no change in temperature taken place. So it means that the only right answer is this option A, in which the temperature does not change during the phase change. Hi, this question is about the pressure exerted by this cylinder, which is hollow from inside, and I have shown you here its 3D view. So you can easily see that this is a hollow, and I can consider this is its axis of rotation. Okay, so important thing is you see that this is its thickness, right? So which is basically the value x according to the question, and you can easily see this thickness over here. So this value is x. And one another important thing to note, in the question they have mentioned properly that the radius of the cylinder, which is its distance from the center to this that end, this radius r, is noticeably larger than the x, right? Which means that the r is much greater than x. Okay, so it means that if, let's say, if I take the square of x, right? So I can assume it is 0 because it is comparably very small. So it is placed on this flat surface, and we have to find out that what pressure does it exert on this flat surface if its weight is W, right? So W is its weight, which is passing from its center of mass, and it is exerting force on this flat surface. That is a normal force, and this force is the pull of Earth on the cylinder that we are calling the weight W. Another thing, so what surface is making contact with the flat surface? What part of the cylinder? It is very important to note what part of the cylinder is making the contact with the flat surface. So you would see that it is obviously this part. If I shade it for you so you can see that this is basically the thing that is making contact. Okay, so it is exerting force on a flat surface. So it is very important to note, to find out the area of this surface, which is not pi r square because this is hollow from inside. So how can we okay, so let's see. We want to find out the pressure, and the pressure is always equal to the force, normal force per unit area. So the force here is the weight. Okay, so the W over area A. So area is basically the area of that part of the cylinder which is making contact. So why not, if you find the whole area, like, I mean to say, the area, the complete area of this thing. Okay, so don't you think it should be pi r square, right? Pi r square. And if we find this area, the area of this hollow part, okay, but before we find the area of this hollow part, we must know that actually, uh what is the radius of this hollow part. Okay, so I explain you this, that from the center of the hollow cylinder to this point, the distance should be equals to basically r minus x. The reason is that this distance is the thickness of this side, and the total distance is r, so this will give you the radius of this circular part. Okay, so this is a horizontal circle. Anyway, so if you want to find out its area, so dear students, this area should be equals to pi into r minus x whole square. So I was saying that if you want to find out the area of effective part which is exerting pressure, so that should be equals to the total area pi r square minus this area r minus x whole square. So it is pi r square minus pi into r square plus x square minus 2r x, right? So if you open the brackets, so pi r square minus pi r square minus pi x square and plus 2 pi r x, right? Now we can cancel out this pi r square with this pi r square. And secondly, you remember that I told you the x is comparably very small, so its square is almost negligible, so we can make it almost zero, right? So I think it's not complicated thing. So what is it left behind? So effective area is just 2 pi r x. So hence, when you will find out the pressure, I told you the pressure is equals to the weight over the area that is effective. So it is 2 pi r. So the right answer is option A. If you look at this question, the option A is exactly this. Hi, this question is about an ideal gas, and you see a container which contains an ideal gas. So these are the molecules according to kinetic molecular theory. The ideal gas have a large number of molecules which move in a random directions, with different velocities. They hit with each other and they hit with the container walls as well. So they exert force on it. Okay, now, what is asked in this question? They say if we increase the average kinetic energy of the gas, right, of all the particles, of all the molecules, if it is doubled, then what will be the new volume? But remember the condition which is mentioned, that the pressure is constant. So first of all, we will find out the result by having an equation, an accurate result, but I will also tell you the conceptual side, that actually how the pressure was constant and the volume should increase or decrease. So stick with the video. So finding answer from equation is so easy, right? First I tell you what is the average kinetic energy. It is the sum of, it is an average of kinetic energy of all the molecules, right? And the kinetic energy of one molecule cannot be determined, but the average kinetic energy can be determined from the macroscopic property, which is temperature. So you know the average kinetic energy can be written as 3 by 2 Boltzmann constant times the absolute temperature, which is measured in Kelvin. Now, if they say the temperature is doubled, if it is doubled, it means that the temperature was also doubled. Okay, it simply means that it is also doubled because it is directly proportional to temperature. And by the way, why it was doubled? Because it means that we have given the heat to the gas. So this heat entered into the gas, it increased the kinetic energy of every particle, and hence the speed has increased. Okay, so when the speed has increased, these particles have exerted more force on the piston. on the piston of this container, and it is perceived, it is most probably that the gas should expand. Obviously the gas will not compress, okay, because now the gas possess higher internal energy, okay. So well, I will come towards the conceptual approach later also. But if you apply equation, which is obviously, which equation should we apply, that is PV is equals to nRT, because that is for an ideal gas. So what factors are constant? So this is a gas of a fixed mass. So the volume can be written as nR over P if I write it in a one bracket, because all the things inside the bracket is constant times the temperature, right? So dear students, this is equation number one. You can say that this is the original volume. So after doubling the kinetic energy, I told you that the temperature will be doubled. So the pressure is still same. So this is a new volume is equals to n is a constant, r is a gas constant, and this is the T prime. So V prime is equals to n r over P into T prime, and you can put the value of T prime here, so which is 2T, okay, because we have double the temperature. So if we substitute the value here, so it will be equals to nR over P into 2T, right? So obviously what it is getting to, so it is, you can write it like this. So it is 2 times nRT over P, which is the original volume before doubling the kinetic energy. So V prime is equals to 2V. So that is the right answer of this question. Now let's talk about, on a conceptual side, it is good if you understand it as well. So the right answer should be C, which says it is 2V and not the other answers. Now, just quickly go through this idea that why the pressure was constant. So we know that the pressure is equals to the force over area, and here they are basically talking about the pressure of a gas, right? So why it remained constant? The reason is we know from the Newton's second law that the force is a rate of change of momentum. So delta P over delta T over area. Now here the area is, dear students, is the area of the piston, right? Which is not going to change. This area is obviously remain same before and after doubling the temperature, right? So it means that the only change that happened in a system is about the force, right? Something happened, the force remained constant. And why the force remained constant? Because force is a rate of change of momentum. So what we did, when we have delivered heat to the system, the molecules are now moving with the more velocities, right? So when they are moving with the more velocities, so this change of momentum will increase, because this is equals to negative 2 mu if a particle have a mass m, right, and the speed is u. So it is negative 2 mu over delta t. So what happened, when you have increased the temperature, the speed of the molecule increased, but at the same time, to keep the pressure constant, the gas expands, right? Why gas expands? Because this time factor should also have to increase. Only in that case the force can be constant. So I hope you understand the logic, that why the pressure is constant, because force is constant, and why the force is constant, because the momentum changed, and the time that took two particles to approach each other, they changed by the same amount, so that their ratio remained constant. Okay, so this is why the pressure is constant. So it means that the volume will increase. So that's why, and mathematically we have proved that this should be 2v. Hello. This question is about the simple harmonic motion, and on the screen you can see the velocity time graph of the particle which is executing the simple harmonic motion. Now, since they have said it's a simple harmonic motion, there are various examples of simple harmonic motion, and one of that I will show you on the left hand side of my screen. So the simple harmonic motion is a special case of oscillatory motion in which acceleration is directly proportional to displacement. but always directed towards equilibrium position. So this velocity time graph shows us that at the time t is equal to 0 seconds, the velocity of the particle is maximum right at that point, which means it is maximum negative. And the one of the famous example of SHM that I'm going to show you is the mass spring system, horizontal mass spring system, which you can see on the left hand side. So I've shown you the different the mass spring system setup, which is actually showing you the different positions. I will talk about them later. So right now this is our equilibrium position, and this must be the positive extreme position, and this must be when the particle, when the mass will have a negative on a negative extreme position. So right now you can see that going to show you the position of the mass at equilibrium position. Velocity can be only maximum, either it's positive or maximum negative can be at equilibrium position. And it shows us that the displacement, sorry, the motion is towards left. So by the way, what we have to do in this question, we have to draw acceleration time graph, which will be one of them. So let us see. So so in order to check the acceleration time graph, that how the acceleration will change, first of all, we should give the values of time, right? Because this is a half cycle. So I would say it is t by 2, right? So the same is here, it's t by 2. So and here is the one complete cycle, one complete oscillation is completed. So this is t. Don't you think that whenever the object is at equilibrium position, where the displacement is zero, it means that acceleration is also zero, because acceleration is directly proportional to displacement. It means that our graph will start from the origin. Either it will be a positive sign or it will be a negative sign graph. We will decide it later. Secondly, if you notice, at that point, if I draw a tangent at that point, so the tangent is a horizontal line. So if I find here the slope or the gradient of the velocity time graph, that gives me a zero value, which again shows us the same concept that acceleration must be zero at the time t is equal to zero. Now let's talk about this point. At this point, dear students, which I can say the instantaneous time is t by 4, right? T by 4, and since the object is moving leftward, so in that quarter time, this object should be exactly at the extreme position, means that at this position. And don't you think this is a position which we say is a negative extreme position, so where the displacement is maximum negative? But since the acceleration is directly proportional to displacement, but it's in opposite direction always, so it means that at that point, the acceleration must be positive maximum value, which is exactly endorsed from the graph when you try to find out the gradient. So I will show you this, that this is the tangent line, and this tangent line has a maximum slope or gradient, which means that the acceleration has been started from, I mean, increasing from 0 to the maximum positive value. So that I will exactly show you here. This is acceleration time graph, and right at that point, you can see acceleration is going like this. So which means that all of the options, like B is wrong, C is wrong, and even D is wrong. So option A is the only right answer. But please, before you leave the video, just quickly see the other positions. So next position is this one, and notice that tangent line is horizontal, which clearly means that acceleration must be zero. It means that this graph is now confirmed. It's a positive sine graph, and that will go on like this. So it's two cycles, and how the particle will change its position. So these are the different positions, and I'm going to show you exactly the instantaneous times as well. And after one quarter time, it will return back to its equilibrium position, and that will be a completion of one oscillatory motion of this SHM, and these are the graphs, and I hope you understand the whole answer. Hi, this question is about electromagnetic spectrum. X-rays and ultraviolet are the two main parts which have significant applications in technology and in our everyday life. So we have to identify that which one of these four statements are correct. So let's analyze all of them one by one. So this is your option A, which says about that in vacuum, X-rays have a higher velocity than ultraviolet. So first of all, you know that electromagnetic waves can travel in space. So they does not require any medium. Okay. And all of the lights, either visible and invisible, they can all travel through the vacuum at the same speed. They differ in frequency, they differ in wavelength and energy if you take a single photon of every light, but all of them can travel through the vacuum and they are not mechanical waves. So, which does not require any medium for their propagation. So, all the waves have the same speed, that is approximately 3 times 10 to power 8 meter per second. Okay, irrespective of their wavelength and frequency. So, that's why the option A is wrong. Now go directly to the option D, which says that the microwaves are positioned between X-rays and ultraviolet. So for clarity, I have shown you the whole electromagnetic spectrum. So you see the first is X-ray, which have a minimum energy, a minimum wavelength and a maximum energy, right? And the last one is a radio wave, which have a longest wave, approximately up to 1000 meter, and have a minimum energy. So microwave is clearly, even it has a less energy than visible light, so it is not between the X-rays and ultraviolet. It means it is not positioned between them. So it means that option D is wrong as well. Okay, now let's talk about the option C, which talks about the ultraviolet wave can be diffracted because ultraviolet's wavelength is more than the X-rays. Okay, maybe on this basis they are saying that it can be diffracted, but X-rays cannot. So please clear your concept that all the waves, either those are mechanical waves or electromagnetic waves, they can all diffract. Now, up to what extent they will bend, they will spread across the obstacle, it all depends on the size of the slit or the size of the obstacle and the wavelength of that wave. Let me show you. Okay, so to analyze the option C, I have taken the two basically the identical slits which have a same size, and right now I'm going to show you the diffraction of ultraviolet first. And for this I'm right now making the wavefront, so I am intentionally making more separation between the consecutive wavefronts as comparable to X-rays. So now you see that the ultraviolet will diffract more. So any wave which have a longer wavelength, it always shows more phenomena of diffraction. It always bends at a wider angle as comparable to this one. So X-ray have a less wavelength, so you see that it is just bending from its edges. Okay, and this is how. But anyways, this diagram shows that both can diffract. So it means option C is wrong as well. So last but not least, the option B must be correct because this is only remaining behind. But I'm sure that you will be interested to know that why this is correct. So X-ray possess higher frequency compared to the ultraviolet. Yes, X-ray possess higher frequency. First of all, this diagram itself shows us that X-ray possess higher frequency because X-rays wavelength is smaller than ultraviolet. Okay, but I want to go in a depth and want to tell you that what exactly X-ray and ultraviolet looks like. So these are electromagnetic wave. The axis that I'm going to draw right now is the axis of the propagation of this wave. This axis shows us propagation of magnetic field in that electromagnetic wave. Okay, because electromagnetic wave is always produced due to the perpendicular oscillations of the both fields. and this vertical axis shows us the propagation of electric field. So right now I'm saying that this shows us the electric field, and this shows us the magnetic field propagation, whereas the electromagnetic wave is going across the x-axis. In that direction it is propagating. Now, so dear students, right now you can see that this is a wavelength of the ultraviolet, okay, from the one peak to another peak. And I think you can guess easily that this must be the wavelength of X-ray, which I have tried to show you that its wavelength is less than the wavelength of ultraviolet. So the answer B is correct only. Hello. This question addresses the addition of the two waves, the overlapping or the superposition, whatever word you have heard in your class. This question is about the addition of the two waves. So basically, this question is directly addresses the concept of superposition, principle of superposition. So first of all, I clear you the concept of principle of superposition, which states that if the two waves overlap, if two or more than two waves overlap with each other, then the resultant wave's the displacement is the algebraic sum of the displacement of individual waves. No problem. I will show you the diagram, especially the diagram of this question. So what we see in this question, that the two pulses, this pulse and the pulse, which are both identical in shape, they are traveling opposite of each other. So at some point they will start overlapping with each other. They will add up, and then what will be the shape of resultant pulse? That's what we have to choose from one of them. So this pulse is traveling in this direction, whereas this pulse is traveling in this direction, whereas they are moving on a same medium. Okay, so what you see here, that let's say it has traveled a little bit distance to the right, okay, and it has traveled to the distance to the left, like this. And right now, this must be this must be here. Exactly, they are about to overlap. Right now, they are not producing any wave because they have not started overlapping. They have not started superposing with each other. In the next diagram, I'm going to show you their maximum overlap, their maximum superposition, and that can happen only when these two pulses will be over on each other perfectly. They will sync with each other. So see here, I have tried to show you like this. Okay. Now they will produce the same shape of pulse, but the difference will be just the amplitude of that pulse will be the twice of the amplitude of the single pulse. So, dear students, it means that the resultant pulse must be something like this. Okay. So, this is your resultant pulse. So the right answer should be option A, not B, C, or D. Okay. But might be if you are thinking that if I have skipped something, that what happened when those two were not perfectly overlapping, when they were combining with each other. So that's I thought I will show you at that place that what will happen. So actually, if you see this part, if you see this part, that in this part the displacement is not equal, it is increasing. So why it is increasing? When the two waves are getting close and now they started overlapping, so their displacements are adding up. Okay, I show you. And to clarify this concept, I am showing you the three shapes which are happening at the three different times when they were getting close. At initial time, like they are at this point, okay. So their both displacements will add, and they will give you this point of the resultant wave. Okay. Now when they will get more close, so now you see that at that point, if you add the individual displacements, then it might represent this point of the resultant wave. And in a third, at a later time, if you see now, they are almost very close to perfectly overlap with one another. At that point, their resultant displacement will represent this point of the resultant wave, and finally they will be in this form, and then they will produce this type of pulse. So I hope you understand this solution.